but it is. And I know that a lot of the country is suffering through some really bad times in terms of the weather, so I feel a little bit bad for that, but hopefully it gets better where you're at. So that's me. I can stop sharing that now. Yay. Okay, now let me quick share my screen and then just give me a shout out when you're able to see my, I'm going to start with my slides and then I'll walk you through some demonstration of the things I'm going to be talking about. So let me share this screen. You should see my slide deck and just give me a head nod that you see it. By the way, I can't see the comments. What I'm going to do is I'm going to walk through the slides and then probably take a break every couple of minutes just so I can check over to see if there's any questions or even just kind of maybe prompt for some questions. But let me actually go into slideshow mode. If you're, I think you're muted. Okay, you can see. Awesome. All right, so let me get let's go and get started. So the topic, and by the way, thank you for inviting me. It's great to sort of virtually meet everybody, and like I said, is a bit informal in terms of what I'm presenting. So we can keep it informal. I will take a break every couple of minutes just to check to see if there are questions in the chat. Go ahead and fill up the chat with questions, and maybe also raise your hand. When I take a break, I'll check all of that, and we can talk a little bit back and forth on some of the topics. So just so you know who I am, I'm Mark. I am a program manager in the Microsoft Azure team. I focus on Azure Data Factory. And the presentation that I offered to give you today, it's not all presentation, by the way, it's just a few slides with lots of hands-on demos walking you through some samples, is how to do ETL in the cloud when you are essentially working in a data lake. So I call it as Data Lake ETL in the cloud. So I'm on the Azure Data Factory team, so obviously I'm going to do everything here in Azure Data Factory. I'll also be using some Data Lake Store. I'll be using some data flows in Data Factory. And that's pretty much it. So I might be landing some data in Azure SQL Database and some Synapse and whatnot. As I walk you through this, I think one of the things I want you to also be aware of is that a lot of what I'm showing you is available both in Data Factory and Synapse Analytics. So Synapse Analytics is something that we announced late last year as a general availability service within Azure. And within the Azure data team where I sit, it's a big deal for us because it gives you a one-stop workspace that gives you a data warehouse. It gives you a Spark environments, notebook environments, the whole ETL, so all the Data Factory is in there and all that. I typically, when I demo and I do my these kinds of presentations and discussions, I'm still sitting in Data Factory, but I'm trying more and more to do some of this work in these demos in Synapse, and pretty much everything works the same in Synapse. We're still trying to burn down a few of the gaps between those two, but I can talk about that if you like. Any of those topics are definitely open for discussion. But let's go ahead and get started. Let's take a look at what Data Lake Cloud ETL looks like. So I love starting here because this is this kind of, to be honest with you, was one of our driving forces behind Synapse Analytics from a solution in a workspace environment, and that is that we see that the data lake as that sort of common zone, or that raw zone for data to land quickly and to be able to then process and analyze data that's in there. So that's across in the bottom part of the slide. And then, of course, Data Factory is providing the pipeline orchestration and the transformation across that. Now, I say, of course, I always make this assumption that you all know Data Factory, and that's kind of a bad thing on my part. So I'm going to try to level set, come up a few levels, backtrack a little bit for you if I must, in terms of understanding some of the core aspects and principles of Data Factory. I'm kind of excited to dive into the details of ETL with Data Factory and Data Lake, just because I'm very passionate about ETL, and yes, I'm crazy like that. But I'll try to be a little bit more understanding too. If you haven't touched Data Factory very much in the past, I'll try to help out with that. The main concept to take away from this is that this is the sort of canonical reference architecture for Synapse Analytics, and for really analytics in the cloud and in the data lake for Azure. You're going to use Data Factory to ingest that data from these many different sources into that common area, that staging area, that lake. and then do some prep on that data. Now you can use Data Factory mapping data flows. You can use external activities, like you can use Databricks or Store Procs. We have data wrangling. I'll show you data wrangling in the tool. And then you will enrich that data. You'll get it ready for models. You will get it ready for analytical models, for data science models, and then serve that through a either through a Synapse Analytics, some other database, or you can even leave it there in the lake. Right, you can still partition that data, and I'll show you that as well. And then at the end of the day, you visualize that. This is a Microsoft centric slide, so it shows Power BI, but obviously we have a lot of customers that use a lot of other tools to visualize that data. Essentially, at the end of the day, all of us in the data engineering world, and I should say that almost my entire background is data engineering, what we now call data engineering. Back in the day, we called it, business intelligence developer. We called it data warehouse developer. All those things has been my entire sort of lineage. And so always formatting data, making it ready for the business to consume is what we're here for, right? That's what we're trying to do. And with Data Lake Cloud ETL, there's some interesting differences between what you may have done in the past in legacy systems and what you do today. So let me see if I can call some of those out. Let's assume that you are using SSIS today, or tools like SSIS, and you're performing a data integration on premises, or maybe VMs in the cloud, whatever, as long as it's sort of traditional ETL. And I should say that what's interesting about the way that we have worked out our product teams here within the umbrella organization I'm in is called data governance. In SSIS, the roadmap is in our team as well. We see that as sort of the on-prem ETL tool, and the Data Factory as the cloud ETL tool. And of course, you can lift and shift SSIS into the cloud using Data Factory. I'll try to maybe touch an aspect or two of that a little bit in this today, but that takes an entire sort of call out in a session just on that, because there's a lot of different things to be aware of and involved with the lift and shift of SSIS. It's pretty easy, pretty straightforward, but there's enough things in there that you probably want to have a separate session just on that. All right, so if you're going to make that transition, you start to move into Cloud ETL, Data Lake is going to be, in most cases, or at least it really should be, that raw zone, that collection points for your data, which means that your data is going to be messy. So if you start at the top of these bullet points, it's going to be messy, and you got to start applying some data quality rules and do some cleaning on that. So I'll show you how to do that today. The frequency of the data when it arrives is going to be unpredictable. You just never know. You could, the things I see is just, it's wild west out there in terms of data lakes, and you're going to see a couple megabytes of data arriving this hour, gigabytes the next. Tomorrow you get just slammed with terabytes, even sometimes petabytes of data. So your the pipelines you build with Data Factory, we call them pipelines. If you're from SSIS, you probably would call those maybe those might be packages as a factory level, and then the pipelines might be your control flow. Anyway, you have to make them so that they are scalable, and so we built a lot of the capabilities on Data Factory on a couple of services within Azure that scale out for you, like Logic Apps for the orchestration, and then Spark, Databricks and Synapse Spark for the transformation engines, so they can scale out. So another aspect of bullet number 3 is that you're going to see a lot of different file types. You're going to get a lot of Parquet, a lot of CSV, tab delimited JSON, Avro, ORC. Just name a few. These are some of the most common ones that I see from data lakes, and so you need to know how to work with those. Now, Data Factory will handle this for you. When I say you need to know how to work with those, you don't need to know the file formats necessarily, but you do need to know that, for example, Parquet is a schema-rich format. It's compressed, and it has schema associated with it. CSV is just plain text CSV, so there is no schema other than you may have headers or column names, and you have to infer data types. I'll show you how to do that. The source data will change a lot. We call that in Data Factory, we have a term where we call that schema drift. And so you'll see in Data Factory built-in capabilities around handling schema drift, which means that your data changes. So, the files you received today had customer ID as the first column. Tomorrow, customer ID is the third column. And the next day, it's called customer ID 2. That kind of horribleness happens all the time. So you need to be able to be resilient to that. So my 5th bullet is, I should number these instead of bullet. It's a little bullet icons, but the ETL needs to be resilient. You need to build pipelines that can be resilient to changes and unforeseen changes. And then the next one is the performance profiles change on each iteration. This is important if you are moving to the cloud for the first time. If you are building your first ETL in the cloud, not only do we need to talk about data lakes, I want you to know that using a cloud service like ADF, ADF is a pure play platform as a service. The only real piece that is an on-prem option is what's known as the self-hosted integration runtime. It's essentially what used to be called as a data gateway that you can install locally so that you can open up a bridge between Azure and your on-prem protected data. Otherwise, it's purely a platform as a service, which means that the profiles of the performance that you see in test environments will vary from iteration to iteration, essentially from invocation to invocation in the cloud. That's just the nature of the cloud. In the engineering team, we try very, very hard in Azure to avoid noisy neighbors and things like that that can really have big impact on your performance. But just understand that it's going to change from over time. Cloud ETL tools are not the same as on-prem client server legacy ETL tools. Do not expect, so you're not going to see Visual Studio for Data Factory. You're going to see a pure browser-based environment. So you're going to be moving from what we used to call BIDS or Visual Studio to a browser. The last one I want to mention here is that there are going to be strategies you need to apply for incremental data loading and updating data. The reason why that's important is specific to data lakes. The data can be so huge at times that you cannot just always assume that you're going to take an entire full load every time. I've seen many data warehouse ETL implementations over the years that have ignored or sort of parked incremental data loading. It's very important to implement that in data lakes, and it's difficult in data lakes. And I'll talk about that in more detail here. Updating of data is different. If you're going to stay in the lake, if you're not going to land into a database, you need to handle essentially asset properties of data yourself, how to update, creates, deletes data yourself. But I will show you some tricks for that. More words, more bullets. I just want to make sure that we level set on this stuff. These are the steps we're going to go through today. I may not have enough time to make it through all of these. I do have some links at the end with videos. I do videos all the time. And I just realized I have a spelling error on this slide. It's driving me crazy. I'll fix it later. But if I don't make it through all the steps, I do have a link to the videos at the end of the slides that'll walk you through all these pieces, so you can always come back and watch the short videos on your own. Each of these kind of steps is a separate video that I do for our YouTube channel for Data Factory, which is in the links at the end. It just reminded me, I did want to show you something back on the title slide with my name. That is my Twitter, obviously, my Twitter profile there at the bottom, Kromer Big Data. Go ahead and hit me up on there, and I'll make sure that you all have copies of the slides. I'm sure that we can always distribute the slides through through this group as well. But I just want to make sure that if you don't get them, or if you have any other questions, by all means, take down my Twitter and connect with me there. All right, back to me talking. So, whoops, one more. So these are the steps we're going to go through. We're going to stage data in the lake. Okay, get your data from wherever it is into the lake. If it's already in the lake, great, you don't need this step. The tool we're going to use is Data Factory's copy data. That's an activity on a pipeline. We're going to profile and understand that data. So we're going to use Power Query in Data Factory, and we're going to use data flows in Data Factory to do that. Now, I'm already falling into this pattern of calling everything Data Factory. This can all be done in Synapse Analytics too. I got to get into the new world. It's change is hard for me, I guess. Number 3, design your transformation intents on a design surface. Once you have your data, you understand it, what do you need to do with it? How do you need to fit it into your shapes at the end? How do you need to get it ready for the business? Design your transformation intent. We have a design surface for this, both in Power Query and in data flows. Work with a small sample of representative data. Very, very important. Your data can get very large in data lakes. Data lakes, Azure Lake Store in Azure is predicated on the principle of bottomless storage. So don't assume the file is going to be 100 megabytes. Use a worst case scenario. Always sample. sample when you build your logic and you do your testing. Don't try to boil the ocean. Don't create your pipelines and your data flows based on thousands of JSON documents. Unit test your logic with samples. I'll show you this, what's known in Data Factory as a data preview and in debug mode. There was something else I was going to say to this. Let me think about it. I think that's probably fine like that. Yeah, I'll get to more on that later. Number 6, unit test, pipeline debug. That's a little redundant. I probably should fix that one. Number 7, focus on resiliency and flexibility. We talked about that already. And 8, the way you focus on resiliency and flexibility. It sounds good. How do you do it? By parameterizing? Yes, I'll fix that. Essentially establishing canonical models. So know what your right-hand side needs to look like so you know how to get there. And then schema drift, which is the essentially you're going to use pattern matching. You're going to use parameterization. You're going to make generic data flows within Azure. We're going to do that tonight. So that's what I wanted to say was data flows. In case you're not familiar with the term data flows is data transformation. Very similar to what you have had in SSIS. Very similar in Data Factory as well. Last slide of just words, I promise. I feel like this is important to note. Your data in you cannot assume that any sort of data quality checks have been passed when you're working with data in the lake. So use Data Factory to build data quality rules. I'll show you how to do this. Some of the things you're going to want to do: build your data quality rules and then clean that data. Verify data types, data lengths. How are you going to handle null values? Maybe you don't need to. Who cares? Maybe we don't care. You may need to pass your data quality rules and cleaning through data value domain value constraints, or the values within a constrained set of known values. How are you going to handle late arriving dimensions? We're going to do fuzzy lookups. We're going to dedupe duplicate data. We need to get the descriptive data statistics or data profiling. I'm going to try to show you as much of this as I can today. Understand your data frequency distribution. Handle missing values, by the way, which is different than null values, right? Null is, of course, nothing at all exists there. Missing values is you probably have a sequence of values with where one was missing in that sequence. Slight difference. You're going to need to map enumerations. So you need to have some categorical data that may be mapped to codes, for example. And then value replacement so that you can have values that all match the same kind of sequence. Wow, that's a lot of stuff. I just realized it. That is a lot of stuff. We're not going to get through all of it, but hey, at least you can, if you ever need to, if you're a data engineer and you want to show your manager all the stuff that you do, just give them this and say, here's like 1/10 of what I do, and have them understand that it's a lot of work. So the tools in Azure that we have for this are primarily in Data Factory. So I think once you start using Data Factory, you're going to feel like you got a place to solve some of these problems. Okay, I'm going to take a quick pause. I'm going to hit the pause button. And I'm going to go and see if there are any questions that came in, or if anybody has any questions, go ahead and just speak up or raise your hand, unmute, and ask a question. I'm just going to take a quick sip of water before I start showing you how this stuff manifests in Azure Data Factory before I go any further. And if not, that's okay too. I'm still going to take a sip of water. All right, 3, 2, 1, time's up. All right, let's talk about.
Sorry, there is a question. It just Sandesh Nagaras. You mentioned basically cloud ETL architecture includes data lake, ADF, Databricks, and Power Query, right? Is Lambda and Kappa architecture a ETL architecture?
So I'm going to focus today, that's a great question. I'm going to focus today on just batch-oriented ETL. When you start talking about Lambda, you start talking about fast arriving or essentially near real-time ETL, it's a different set of challenges, and I just don't have the time to go into it. With Data Factory is purely batch-oriented. You can get down to sort of what you might want to think of as a micro batch, down to 1-minute increments. But if you want to get below that, you want to get to more real time, you're going to look at event hubs and Azure. You're going to look at other essentially tools. You're going to look at probably ASA. You're going to look at event hubs, those sort of tools to add to your sort of collection of things that you do within Azure to get more near real time with that. Data Factory is purely batch based, but like I said, 1 minute increments usually get to close to what you want to do in a Lambda sort of architecture where you have the hot path and the cold path. So hopefully that answers the question, and I'm not going to touch on it tonight, unfortunately. Good question. All right. So let's talk about data profiling. So data profiling is where you want to begin the journey. And I like to start here because you're going to want to take a look at this data that is arriving into your lake. And you're going to want to understand the data. You don't need to be a data expert necessarily, right? A lot of times you need to sometimes actually do the hard work of talking to your business to understand the data. And so there's always that aspect to it, but the way to really understand the shape of the data and the what's contained inside of there, what are the value distributions, is to use data profiling. So there's 2 different ways to do that in Data Factory. The slide is just a picture. I'll walk you through it in a couple of minutes here. But the left-hand side is using the data flow capability. So data flows in Data Factory versus SSIS has the built-in profiling capability within it, where you don't need to go and do a separate task for it. You just click on the transformation, and you can profile the data at that point in time. So you can see the value distributions on here. You can see the number of nulls. So you can look for things like key candidates. You can look for whether or not you need to fill in missing values and those things. On the right-hand side is look at what that looks like in Power Query. So the Power Query interface is also integrated into Data Factory. So if you prefer to work with your transformations from a data first approach, you can work in that spreadsheet style interface through Power Query, and you essentially get the same kind of thing. You get the value distributions, you get the number of nulls, number of unique values, and so on and so forth. So data profiling, very important to understand your data from a data engineer's perspective. Then once you start finding that some things are missing, now you need to replace values. Now remember, we're working in a data lake here. This is all cloud-based. This is all data lake. So the assumption is that you have your data housed in ADLS Gen 2, and it's all files, right? So you need to, many of these same techniques work just fine in database sources too, but let's assume that we're all working in those different file formats we talked about earlier. All of these transformations and these techniques will work and work really well. You need to now replace missing values. You need to look for things like, what if the length of a title is 0? What do I do with that? Do I turn it into a null, or do I just maintain that title? Or do I make it NA? Right? Many different things that you could do. You need to make that decision. Or again, talk to your business. Understand what that target scenario is and what would make the best way to report and get answers out of that data. Then you can code that into Data Factory. Remember, so Data Factory, when we're working with data flows and within pipelines, it is a code-free environment. So the only coding you're going to do are these functions that you're seeing on the screen here at the bottom. These are very Excel-like, very M-like, very DAX-ish, that kind of stuff. But these are going to then equate into Spark functions. So you're going to get that massive value out of executing your pipelines and your ETL at scale on Spark without needing to know Spark. Just know what you want to do with your data. At the bottom, under this aggregate, I am converting this rating column to first what I'm doing is averaging that, and then I'm converting it to a decimal value. So this is casting it, and this is aggregating it. And the environment that you're going to see when we're in Data Factory is very, very rich from a scripting environment. We really took the idea of what we have from scripting in SSIS and took that to the next level. We felt like that SSIS scripting environment is missing some things like IntelliSense, autocompletes, much more helpful environment to make you more productive in Data Factory. Now, a very common thing you're going to do is you're going to split that data. And one of the reasons you'd want to do this is because you need to have your data presented to many different teams. The data lake is that centralized landing zone. Now you're going to have your data scientists. You're going to have your business users from many different business units that need to access that data. So you're going to split the data. What's known in SSIS, I believe we call that the multicast, is here inside of data flow and data factory known as a new branch. So in this case, I'm taking a branch of my transformation and I'm saying new branch, and now I can work on that data in different kinds of ways for different teams without needing to make a brand new data flow. So splitting is a very important thing that we're going to talk about. This is the pattern matching. I talked about how you need to account for changing names within your data. You're going to have schema drift, you're going to have data drift. Well, we give you a way to protect that and make your data, make your pipelines resilient. So resiliency in your process is a very, very important aspect to data lake and ETL in the cloud. And so what I'm doing in this case is I am trimming every column that is a string. I don't care what the name is. This allows me to protect me against changing column names. I'm just going to say any data type that's a string, trim it. And $$ is the syntax in Data Factory data flows that just means it's essentially it's a meta function that means the current value. It's the same as if you were saying something like this in a an OO language. If the type is an integer, then I want to change it to integer. Maybe this isn't great. I'm not sure why I'm to integering an integer, but you essentially can apply this to any type of field based on the data type without needing to ever know what's the name is. These are other things you can do. You can find the name, and you can do things like you could actually use regular expressions, and you can use matching patterns on names. You can match on ordinal position within a file. Many different things that you can do to address the metadata within your sources. So then when you have enumerations within your data, here's how you're going to do things like a case statement within your data flow. This is important because the reporting at the end or the model that you're loading may need to have these codes translated. So notice that I actually hard coded these into a derived column, what's known as a derived column within Data Factory. I could have also done a lookup. Another way to do that is to do a little bit more dynamic, is to have a lookup. So I could have had this in a table or in a file somewhere and then done a lookup. Again, so the lookup option is down here. In this case, actually, I did a join, not a lookup, but essentially the same thing, where I can say, go ahead and find the string value that matches this code. And that way it's more dynamic. I don't have to go into the code or the data flow and change it every time a code changes or a new code is found. All right, it's a very, very important thing you're going to find when you are, especially when you're joining or you're looking at multiple files within your lake, is going to be deduping your data. You're going to find a lot of duplicate values in there. So one of the really nice things that you can do in this kind of an environment is that you can bring in all of those files. So a single source in Data Factory can read and from an entire folder of files. So all of the rows, all the values from all those files can be put into memory. Because this is using Spark, what happens is each column within those source files will get read into data frames and stored in Spark, which allows you to mash together all the different values found from your source data. Now you can do deduping on that. So my dedupe in this example is very, very complex. You don't need to get this complex. I'll show you a real simple dedupe process that you can add to your factory in like probably 2 minutes. This I do have this pattern, by the way, saved as a template as well. And I'll show you how to do pipeline templates. But this is using fuzzy lookups. This is doing things like do a fuzzy match on names, then do a like match, SoundX on what is this doing SoundX on? This is doing SoundX on, I think it's probably doing names as well, actually. I think I did it twice, maybe first name, last name. And then I'm looking for phone matches and zip matches. So those, then each one of these as I match adds to a running total, or essentially a percentage of likelihood that it's a match. So if these 3 types of things, looking at actually 4 things, fuzzy match on a name, SoundX on a name, that's 2, phone is 3, group is 4. I have zip on here too. So that's actually, this is all phone. That's zip. So there's 4 things. Okay. So those 4 things, if I if I apply a 25% a ratio to each of those, now I can get a percentage of likelihood that this is a match. And what I can do at the end is I can say that if the final result is, let's say less than 75%, then it's not a dupe. If it's 75% or greater, then it is a dupe. So I use a conditional split here, not split here, split here, to say that. So that's a way to do duping. It's a little bit more complicated than just saying an exact match. This is doing likelihood of being a duplicate. Here's what the fuzzy lookup looks like. So when you're doing a fuzzy, oh, by the way, fuzzy lookup, so important in Cloud ETL in the lake. The reason for that is because your data quality is not guaranteed at all. It's going to be messy. It's going to be dirty. This lets you do things like use soundex on those to see if in this case I'm matching on movie titles. See if that movie title sounds like the other. It may not be spelled exactly the same. There may be capitalization differences. This way you can do fuzzy matching and fuzzy lookups. Very important in this kind of a less clean environment. Metadata rules. Let's do some column counts. Let's look for schemas that don't match the expected schema, and then just reject those. So having a very flexible sort of generic pattern is great, but you may have a bar that you've set. Set a baseline to say that, okay, that's fine. I'll take in your bad data and I'll try to process it. But if the schema doesn't at least match this rule, I'm just going to reject it. Okay, so build those rules to do that. I have an example video on here on how to do that. And I also have an example I'll show you in a minute. I should have taken this one out because that's a duplicate slide. And I'm guilty of editing my slides during the meeting I had before this. So I apologize for that. Slowly changing dimensions, I'm probably not going to have time to get to. I'll show you the templates for it. Slowly changing dimensions are still very valid in ETL in the cloud. When you get to this point, you're now talking about A, incremental loading, B, how to update the data. So the update data in the lake is tricky, and we'll talk about that in a minute. You're going to do your fact loading and incremental data loads. So incremental data loads, the way you're going to do it is, in this case, I'm using Delta Lake at the top. I'll show you how to use Delta Lake. Delta Lake is very good for incrementals and very good for updates and deletes. The bottom is showing you how you would look for incrementals if you wanted to hand code this yourself, in which case I'm hashing. So I'm building hashes using MD5 of my column data, and I'm storing that. So I can, when I go to query on my next iteration of this execution of this data flow, I can say if there is any change, or do the other way around, if this MD5 hash, if this row fingerprint is exactly the same, then just drop that row. That is not a change. Only give me the deltas. There we go. I made it through the slides. So when you get the slide deck, I'll make sure that you have a way to get these. A lot of these are videos on the ADF YouTube channel. Just look for the ADF YouTube channel. I'm sure you'll find it through Bing or Google as well, and you can look for it there. So now let me show you how this stuff all looks and how you're going to do all of these things. And I'll try to go slow to give you a way to get started and save some of the more complex things for when you have more time for it or when you get a chance to watch the videos. But what I want to do before I actually jump into the demos is do a quick pause, get some more water, and let me see if we have questions on this before we move on. That was the one question I did answer that. Oh yeah, go ahead.
No questions so far, Mark, but you please, you can unmute and ask question if you have any.
Otherwise, just give me 1 minute while I get my browser over here. Okay, here we go. Yes, by the way, that Lambda question is one that we should follow up on at some point. We're actually doing some work in Data Factory to handle more of sort of like that CDC kind of model as well. But for now, like I said, if you want to build a more real-time, I would use look at Event Hubs, look at Stream Analytics, those kinds of things. All right, let's go ahead and share the other screen this time. Actually, no, I'll just share this one. And there we go. Do you all see my data factory? I'll put it this way. If you don't see it, just go ahead and shout out. Let me know. All right.
Mark, we got a question if you'd like to answer that.
Yeah, sure. Go for it.
Okay. It's from Chandu. As he mentioned that, as we are discussing about ADF, one weird behavior I observed when I move Oracle blob data, it appends hash in CSV storing data lake. Any comments?
Interesting. That's interesting. No, I haven't heard that before. CSV stored in the data lake. Oh, it sounds like it's actually putting it in the CSV data. That's interesting. That's something that I would like, if at all, if you could maybe send me or actually make a ticket on that. I'd like to kind of have engineering look at that. I haven't heard that before. That certainly sounds like something that we're doing wrong or something's misconfigured on that. But no, nothing kind of pops in my mind in terms of what would cause that. But let me do this. I'm sharing my screen now, and to that point, I do want to point something out. So to me, that's step one, getting your data into the lake. That's exactly what we're talking about there is Oracle data. Let's say that's Oracle running on a VM. And when you want to put that into the lake, you would land that into Data Lake Store. And the way to do that is you would actually make a pipeline. So this is Data Factory. So to make a Data Factory, you'll do that from the portal. The Azure portal is over here. I'm going to probably, I do have my mask on, but I know I have some things that's sometimes I don't like when I show, so I'm gonna just leave it like this. But essentially, when you go to the portal, you'll look for Data Factory, and then you'll create a new Data Factory. There's no cost for making a factory. The only time you pay to Azure or Microsoft when you're actually executing your pipelines and your data flows. So what you can do is you can sit here and you can build until you turn on the debug. You can just build and you can design without any cost. But what happens is if you're going to, let's say, bring in Oracle data and land that into the lake, that's step one of your sort of lake process, your ETL in the cloud process. And so you'll make a new pipeline. So in your factory, you'll go to the new button up here under factory resources, and you'll make a pipeline. You can see that the top level resources within a factory are pipelines, data sets, data flows, Power Query, and templates. Okay, templates are really cool. These you can make yourself, so you can share your common patterns. Power queries are how you would do sort of data wrangling. Data flows are the primary ETL pieces we were just talking about a second ago. Clear my filter on there. Data sets are similar to what you have in other tools for data sets like SSIS or Power BI. They define what your data looks like. And then pipelines are the primary unit of that you're going to work with in Data Factory. And this is my pipeline here. This is a new pipeline. You see, I get a blank design surface, and then I have a toolbar over here, like you would maybe see if you're an SSIS user. And when you're going to go and grab data and put it into the lake, the first thing you want to do is copy it. And so you'd use a copy data activity. And the source in your case is going to be an Oracle database. And you'll see that we have about 100 connectors. So the connectors for these different sources are out of the box in Data Factory. You don't need to go and download anything. You just use these. But if your Oracle is sitting on-prem, or actually it's, in all cases, it's going to be something you need to do this, which is you will build what's known as a self-hosted integration runtime. That is your gateway into your your data that is not in Azure. So to get to that, you're going to click on this button over here called Manage. And then you'll go to what's known as integration runtimes. Integration runtimes are the engines that essentially our Data Factory uses to process data, to move data, to transform it. You get this one that you get, actually I had created these two. This one right here, the auto resolve is given to you out of the box. When you spin up a factory, you get that one. That already starts up, and that is running on Azure. If you need to run something on-prem to get to your data or on a VM, then you would create what's known as a self-hosted integration runtime right here. This will walk you through it. This will walk through what you want to name it. It'll help you in terms of setting it up. You will install an agent on a VM or on a server. in order to open up that connection between Data Factory and your sources. When you do that, now you can finish your copy because that's going to be your source. And then your sink is going to be the data lake. And I have a folder, which is right here. And so all of my data will just get dropped into this folder. And you can then change settings on here. You can do things like you can set how much parallelization you'd like. You can set what's known as data integration units, which is really kind of a knob that you turn for how much horsepower you want to give to your copy activity. So once you do that, your data is now in the lake. And so your next step could be you want to prep that data. So I actually have a more complete example that I'll show you. Let me go over to this one over here. So there's my ingest lake, my copy data. And now I added a Power Query onto it. So the way you do that is, let me go back to my brand new pipeline over here. You go under the Power Query category and you drop a Power Query on here. You connect these things this way. When you connect, you can also click on this button right here and you can say connect when it succeeds, fails, on completion, or when it's skipped. So I'm just saying on success. So this will block and wait for this to complete, and then it'll run the Power Query. The Power Query I'm going to use for data wrangling. So let me show you what I mean by that. Over here on my finished pipeline, I called it as clean names and values. So let me double click it and show you what happens. This will actually launch the Power Query interface inside of Data Factory. Now I can do my cleaning on that data. The data is sitting in the lake. So I'm in the cloud, I'm purely in the lake environments. And now this is going to sample, right? So what happens is inside of Power Query, you will see under options, project, I know I was going to click the wrong thing. Under options, global options, you will see the that you can set the profile based on 1,000 rows. And this data will be able to be sampled within the environments inside a Data Factory. So here's my profile of the data I was talking about earlier. I can see that it is a 99.8% distinct, 99.6% unique. I can look at the distribution of the values. And then I can start working on this data. So every time you apply a transformation to this data, you get a new step over here. If you haven't seen Power Query before, this is the exact same interface in Power Query. If you like to hand code this stuff, you can do that too. There is the ability to actually edit what's known as the M code, the M script right here. That's fine too. I like to use the interface, and each step I take on my data gets added as a step over here on the right. So you can see that I filtered some rows, I removed some columns, I changed some column data types, and then I sorted the rows at the end. And of course, you can always take some steps out, so you can remove my sorted rows at the end, and now you just have these 3 steps. And then if I want to sort it again, I'm going to click here, and I'm going to say sort ascending. And then I'll sort the data and then put here. But you can see why, if you're going to work in the Power Query environment, you don't want to work with very large files here. This design environment is something that's meant for smaller amounts of data. When you execute this in a pipeline, we will translate your M into Spark and execute this at scale. But when you're working here in your design environment and you're providing us your intent, you're building your query, your script, just stick here with smaller amounts of data. You could always make data sets that represent both. So you can make a data set that is both your test data set, which is maybe just 100 rows, and then your full data set, which has no filter on it. That's just a good practice when working in the cloud. All right, so I'm fine with this. I'm going to save it, and then I'll close it. And let's move on to the next step. Oops, I gotta wait for it to finish, my bad. By the way, when I'm saving in Data Factory, I'm actually saving in my GitHub. So notice I've hooked up GitHub to my factory. So this way I'm not writing directly to the Data Factory service. I am writing to my JSON files inside of my GitHub repo. And then when I'm done and I'm ready to, I've done my testing and it's done, I can click publish. And then it gets pushed up into the cloud service. So I highly recommend that you hook up your GitHub or your DevOps to it. And then you can have branching, you can have collaboration branches. Yeah, it's a very nice environment to work in.
Mark, there is a question related to Power Query.
Yes, go for it.
Joel mentioned, how did the Power Query activity know which file to connect to?
Oh yeah, so okay, so what happens is a couple of things. Let me do a new one and I'll show you. So you can actually just make a Power Query in here. In fact, you can make a Power Query inside of your data factory and not even use it in a pipeline. You can just use it just to explore. So say I want to take a look at my data and understand it, and then close it, and don't even make it part of my pipeline. I only made it part of my pipeline here because every time I run this, I want to clean those names and do the exact same things I just did to that data. Okay, but let me show you. So when you open up Power Query, this is going to open up a Power Query Online instance in the region that my factory was built in. It's going to use that region. And then it's going to use the Data Factory data sets. So we translate Data Factory data sets into Power Query data sets. So if I take, for example, my movies data, this is data in my lake, and I say, okay, it'll go and read that data. This is about 9,000 rows. This should work just fine inside of Power Query. And then it'll present that to me. So use data sets to do that. And what's really nice, because if you're done exploring and you want to make your steps part of your factory pipeline, when you go back to your pipeline, what you can do is, at the bottom section, you can set a sync to this. You can say, oh, that's great. I love what I've done with this, but I actually want to save this as an Avro file. Remember I talked about how, actually I don't want to do it as Avro, let's do it as Parquet. Remember I talked about how common formats of files you're going to find in the lake? So let's say that your end process that needs this ETL's data needs it in Parquet. Now you can use Power Query to do that and then not export, but essentially land this data as Parquet. And then this will be fully partitioned because it's all in Spark. You don't need to worry about any of that business about partitioning. Just explain to Power Query or to data flows and Data Factory what you want to do with the data, and then we'll do the rest. Hopefully that answered the question. If you have more, just go ahead and type it in there and I'll come back to it.
Since actually you were talking about the Git, I think there was a question related to Git or like collaboration, Jason, he mentioned we have a problem with multiple people collaborating on a pipeline. They often override each other changes.
Oh, geez.
We're under impression that changes in pipeline, even using Git, are not mergeable.
So what you have to do is you have to follow very, very strictly the Git's process of everything's got to be done in a branch. So you all need to have your own branch, and then you essentially issue a PR, a pull request. Okay, so create a pull request, and then you can manage the merge process that way. Don't work from the same branch because then you'll just be overwriting files. Work from separate branches, pull request, and then merge to your master branch. So you got to follow that strict Git process to avoid that.
Yeah, Jason, I also would like to add with my experience. Actually, we are like 4 or 5 people working in ADF, and we're strictly following Git rules. We never had that issue, exceptionally 1 or twice for the same data that we're working. Maybe had conflict, but we resolved the conflict.
Yeah, the conflicts, right? That's part of the process of resolving those conflicts. But once you are in branch mode, you won't be overwriting files, but you will still have to, yes, you will still have to handle those kinds of conflicts. Now, what happens is, one thing you should keep in mind is that this is something that trips people up when you start using Data Factory with Git all the time, which is that the deployments unit within Data Factory is the factory itself. So this entire set of stuff, this entire factory, if you want to just deploy parts of it from a branch, you can do that now. There's a new option to do that. And we actually have that enabled through an NPM package in DevOps. So you'll find the docs online for CI/CD in Data Factory, and there's a link to download that. So if you'd like to maybe just cherry pick a pipeline and have that deployed, because our deployment unit is factory, not deploy the whole factory, you can do that now. But the deployment unit is factory. It also leads you to think that when you start getting more complex, you may want to separate some of your factories. And that's absolutely fine. The reason why a lot of folks don't like to separate factories is because then these artifacts aren't shared across them. So it's a give and take. There's pros and cons of doing that, but just kind of keep those things in mind. Those are great questions. We should have a separate chat on. There are CI/CD modules and videos online too that we try to go through some of those challenges and how to work through those. Great. So let's get back to this cool pipeline we have here, where we are getting the data out of the lake and we're working with it. We cleaned it. We replaced some. I don't think I actually did replace any values. Oh, I cleaned names and values. That's all I did there. Now we're going to dedupe. Okay, so I deduped with the data flow. So let me go back to the new pipeline that we're building. This pipeline over here. The way that I deduped is I added a data flow. So add a data flow. Connect these two things. So I've brought the data in from Oracle. I've landed into the lake. I've ran a paraquery on it to do some data wrangling on it, to do some prep, and now I'm going to dedupe it because it's in the format I need, so I'm going to dedupe it. So the deduper is over here from my data cleaning. Double click. Very, very simple data flow. This is the data flow. My source is that data that's in the lake, so I use the exact same data set name. And all I do is add an aggregate. So the way that you construct data flows in Data Factory is you click on the plus sign. This is a construction paradigm. This is not a free-form acyclical graph. This is construction paradigm. So we make it as easy as possible to build compact graphs. We found in SSIS over the years that we got these kind of, sort of ridiculously gnarly graphs for data flows. So we wanted to try to avoid that. That situation. So what you would do here is you would add the things you want to do here. You can do your sorting, your filtering, your derived columns, aggregates, and all that. To dedupe, you add an aggregate. Now this is the simple dedupe. This is deduping across exact matches, not the complex dedupe I had in the slides. The way that I dedupe is I group by a row fingerprint. I make a fingerprint of the row by using SHA-2. So columns, let me actually show you what this environment looks like, by the way. This is the scripting environment in Data Factory data flows. We made this very, very rich. So as you type, you do get IntelliSense. Both of our built-in functions, this is our list of built-in functions. Hopefully you're seeing all those. Did you write them all down? There's a lot of regex in there too, so I know folks that like to use regex. There's no problem that can't be solved with regex, by the way, in case you didn't know. But it also has the input schema. So you could also do a, you also get IntelliSense on your input schema too. So anyway, what I'm doing here is I'm using this function called columns. If you hover, you'll get help on that function. The columns function is saying all of the values from all the columns in that row, and then SHA-2 is giving me a hash of those using 256 bits for that. So this is saying that I want to have a SHA-2 256 and fingerprint that row. And that means that anything that is an exact match will come out. It'll filter because I'm grouping it in the aggregate. And then what I say is, give me the first. Okay, so you could always change this and say, give me the last. It doesn't matter. This is just deduping, and the rows are exactly the same anyway, so it doesn't really matter. If you don't want to do it every row, just go ahead and type in the columns that you want to match on. You could say match on title, match on rating, and you can start typing it that way. And you can do that too. If you have a syntax error in here, it'll just give you the typical red squiggly that you're used to. You can hover and it'll say that that column is not found. Let me cancel this so I can keep it the same. Now what you can do is once you're in this.
Sorry, Mark.
Yeah. No,
since you're in the function, sorry, there's a question. Since you're in the function, it's like, does it allow to write custom function?
That's a great question. We do not allow that yet. That is something that we're working on. We don't have that done yet, but it's something we get asked quite a bit. The one thing I want to stipulate, just so you understand, so we're all on the same page, this environment that you're working in when you're doing this is a Spark environment. An ADF, in Data Factory, this is actually spinning up a Databricks cluster in the background for you. And we essentially, ADF manages that for you. You don't pay for it. So you get 1 meter, which is your Data Factory meter. We bring the environment and then we tear it down. It's a fully ephemeral environment. What that means though is that we don't allow custom code on there. Now, if you want to make your own function, there's a couple of things that you can do. One is you can, let me go over into, let me just quickly add a derived column in here to show you. Derived column is where you're probably going to do most of your work within Data Factory when you're making a data flow. There is this idea of locals, essentially what are variables. So you can create something that is custom. You can say, I want to trim, this is a dumb example, but let's just use it. Just stick with me. Let's trim year. Okay, so if I do that, I can call this my trim and I can use it. So I can combine the things that are already there in my own interesting way. If you have some intellectual property that you maybe have as a jar or as Python code, you can't do that. That is something that we're looking at doing though. And by the way, if you want to, all you have to do, because this is the nice thing about Factory, is inside of my Factory, if now there's something, if I've done my data flow, but I needed to do something that's a bit unique that wasn't in the function language, by the way, I would challenge you to say, if you can't find something in our function language, let me know and we'll probably add it. There isn't that much, it's not there. Let's say there is something that's unique. Maybe there's a specific internal rate of return function, I don't know, that is unique to my business and it's not there. Just add an Azure function on there and build it in Azure function. So when I'm doing my data flow, now I can go ahead and call my unique IRR function and do it in there. So this is where you would put your custom code. Just put it that way. Great questions. So back to my data flow, and that was here. By the way, my browser is slowing down big time, so I think I've got too much open. I apologize if things are getting sluggish on your end. It's getting sluggish on my end too. This always happens to me when I do demos. But I did a data preview and notice that I actually see the data in real time. So as you are building your transformations, you can see what your data looks like, and you can validate your logic. And here's my hash, my row hash for each row, so I can see if anything matches. You can also look to see how many rows there are. So you can see if you are actually filtering out rows by doing a dedupe. And this is only showing 100, and that's because it's only showing 100 in the display. You can set how many rows are sampled. The row limit is 1,000. The display is only showing 100, but I'm actually sampling 1,000. I can say, you know what, sample 100,000 and change that here, or just sample 10, just because I just want a small sampling. Please use this because your data in the lake is going to be nasty, is going to be large sometimes. I'd highly recommend that you do that. Also, if you want to sample more data, I recommend that you change and increase the size of your integration runtime for your debug. So your debug session is predicated on integration runtime. You can change that. This is all controllable. When you click and you build an Azure integration runtime, under Dataflow runtime, you can change that to up to 256 cores. I can say, give me a Mondo memory optimized cluster of 256 cores, and that'll just be a huge cluster that'll let you have even more data in there. That can be expensive. I'm not recommending you do this. I'm just stating the fact that you can increase that if you want to. And I think I'm getting close. I think we're running short on time, so I'm going to try to hurry up a little bit. And I hate throwing a lot at you at one time, so I'm going to try not to show too much. This is a data flow. Let's go back to that pipeline. And the pipeline is right here, data cleansing. And then at the end, all I do is I send an email. So I use the web activity to use a logic app to send an email. Okay, so this is a fairly sort of canonical, very simple example of a pipeline that does work inside of the lake. On my dedupe, when I was using Dataflow to dedupe, I do want to show you that my end result was to another folder. I did not put it into a database. You can absolutely do that. You can go into a database. Let me show you what that would look like. When you build data flows, or you build copy activities, or essentially anything within your factory. And by the way, I know what's happening in my browser. Now my filter is not working, so I'm going to actually refresh this. I had this open since this morning. So when you are, no, I got an easy way to show you. I'm just going to change the sync. The sync type does not have to be lake. I'm just doing that because that was going to be the focus of my talk today. You can absolutely use a data set that is a SQL database. So let's use SQL as an example. So SQL table. It's as simple as changing that. You can change your mappings if you need to change your mappings. This is just saying everything that comes in is going to land into the database, into the end database. Anything that comes from this transformation that was here. If I click on inspect, I will see the names of the columns. This is my metadata. This is essentially right-clicking on the connectors. And this is how you have to see what the metadata looks like. This is what it looks like coming in. Okay. In your settings, you can do things like you can have, you can recreate tables. You can truncate your table. You can run some pre-SQL scripts, like you can turn on or off identity inserts, and those kinds of things. Save it for another day. We want to focus on just keeping the data in the lake here for this example. So let me go back to my folder out right here. Okay, now what becomes tricky when you're working in a lake environment is everything is outputted as a folder or as a file in folders. So when you're working with files, that means you don't have the ability to really update those. So if you're going to do things like slightly change the dimensions or update dimension members, that becomes a bit tricky. Two ways to do it. I'm going to end on this point. Two ways that are really good to do that. The first I'm going to show you is partitioning data. So when working in the lake, partitioning your data in your files is very, very important. Let me show you what the end results would look like. So if I go over to, I think I should have an example in this, these folders here. So let me go back up to this container level here. This is my Storage Explorer right here. And where is my output? Let me sort by this. And if I go to output, and if I go to parts, yeah, here's an example. So in this case, I am only producing my output from ETL based on year. So this key value, this column or metadata equals a value is a very common thing that you'll see in folder partitioning in big data environments. And what this allows you to do is, because you're writing to files, you could have under here, I don't have it this way, but I'll just think about it this way. This rating, instead of 1 to 10, could be months. Okay, and then inside the months could be days, and then inside of days could be hours. So every hour you'd make a new folder with your transformed data in there. So that's the way that you essentially get the same kind of update ability on files. And what you would do then is you would then say, I want to view the data from 2013, from January, from this day. That's the way you can do it. That gets a little complicated and it gets a little tricky, but it's easy to build in Data Factory because we know that that's a pattern. So we built that into it. And one of these has, I just got to find the right one. Yep, it's this one. Well, actually, I did do it this way. I just didn't actually run it. So when you land your data in the data lake, in this case, I'm saying give me Parquet files. I click on the Optimize tab and I say give me key partitioning. So all you have to do now is pick the columns in your metadata that you want to partition by. So I said year, month, and day. I will now get a folder structure, and Data Factory will handle that for me. So now if you go to run a notebook code against it, or you go to run another data flow, just point to that top level. If I point to this parts folder here, Data Factory can read every year, every day, every month out of it and give you that data into a single set of data frames. A little bit of an easier way to handle that or to work with that, in my opinion, is to use Delta Lake. So Delta Lake initially came from Databricks, is now an open source capability. You don't need to really understand Data Lake to use it in Data Factory. In this case, I changed my sync to a Delta sync. And all I have to do is say, okay, I'm going to keep it in the lake, and I'm going to call my table as movies Delta. When you execute this, Data Factory will actually create a table. Think about it as a table, but it's essentially Parquet files that are compressed, and they maintain. Spark will maintain that essentially transaction log for those. So it almost acts like a database. So what I will show you real quick is how to make a data lake. So a Delta Lake. I think that for most people coming into the data lake first, Delta Lake makes this process a lot earlier, a lot easier. Oh my God, it's late. It's not actually late in the day for me, but anyway, a lot easier. So let's do that real quick. This will be my last thing. So let's do a new data flow. Let's bring in data from, let's do the movies data again. All I have to do to make a Delta Lake out of this is just add a sync. Just drop it into a Delta. So I'm going to say, give me Delta. Tell Data Factory where your data lake store is. This is called a link service. This contains your credentials. You'll make a new link service, give it your credentials, and then you can browse that folder path. So my data lake store has a container. I'll just keep it right here under container. I'll make a new one. I'll call this Toronto. I'll just call it Toronto. So I'm going to have essentially a new folder or table for Delta called Toronto. You can set your compression type and all that. I don't need to do that. And that actually, I believe that should really be it. Let the mapping be the defaults. And yeah, I'm going to insert brand new rows. So now just go to a pipeline. So by the way, data flows, you can debug them, you can test them, but they don't actually write anything until you add it to a pipeline. The pipeline is that, again, that Uber unit within Data Factory that you use to execute things from. It's your orchestration. So I called that, it's called Data Flow 3, a real meaningful name, yes. That's it. So I can click the debug button. And because I have a debug session up, that will actually execute that. That will create a brand new Delta Lake form. It'll take about a minute to do that. And then that'll be done. Now, once that's done, I can go ahead and I can do a slowly changing dimension against it. I can update that data. What that looks like when you actually get to that point. If I have this really nice new tutorial I wrote that you'll find online in the Azure Data Factory documentation that'll show you how to do a Delta Lake update. So after you've created it, then you can follow that procedure. But it's right here. You use what's known as an alter row transformation. You can set policies. You can say update my data lake if the year is 1988. If it's 2021, insert, because these are new movies. If it's 1950, I didn't like 1950 movies, so delete all those movies for you. All the steps to do this are in that tutorial. And then let's go back to that pipeline that's running, pipeline 5. And by the way, while this is running, you can look at the details. Click the eyeglasses button, and you'll see what's going on this. So you can see that there are 6 columns being written. It took, let's see, 45 seconds to acquire the cluster for this work to begin. And oops, I didn't mean to click that. I meant to click this. And it's still running. It's taking a little bit of time. I think something in my browser might be creating queuing and delaying on this, but that will essentially complete at that point. So I think I'm probably gonna just pause or put an into it right there and let you sort of ask any questions or anything that you want me to kind of talk a little bit about. There's just too much outside of this I can go into that I think I'll just kind of create things to be a little bit more gray, a little bit fuzzier for you. Actually, there we go. So it did succeed. If I go back to the eyeglasses, I can see that we landed, it's not showing me that we had 9,114 rows. It took just 5 seconds to do that. It took 29 seconds to actually write it within the sync. And if I go back to the pipeline, let me just check one thing on this, see if that's the reason why I'm not getting more output. If I go to the settings, and is verbose, that's actually all fine. I'm not going to go into any of those other details, but this is the detail of what happened. So it took about 1.5 minutes to create that. And now I have a Delta Lake in the data lake with 9,000 rows, and that's all I have to do. All right, let me pause there and let me see what questions y'all have. I'm going to grab a little bit of water here.
Sure, Mark. There is many questions actually there. Well, I think I'll just start from the last one. Chris was asked if every developer chooses their own partitioning strategy across a data lake, that seems like a chaos. Any best practices for configuring that as a standard across all developers or code?
Yeah, that's a valid points. For sure. I mean, everybody's doing their own thing. I mean, yeah, I think that comes back to standards and practices, and that's a common theme. It doesn't matter what tool you're using, or that's not unique to necessarily cloud data lake ETL. Although I guess in some aspects it is, because if you're writing to a well-established sort of database schema, you don't have that as much of an issue. Yes, somebody needs to set that model of what the partitioning is going to look like, and that does have to be established. Now, in terms of whether or not every developer does their own thing in that case, I think the best way to handle that really is just going to be set that standard within your organization, and then everybody has to abide by that. There's not really any other way to control that. Yes, chaos is bad. Agreed.
Well, there is other question related to data provisioning to Power BI. So what are the best option for provisioning data into the Power BI service from ADF? For example, is it Power BI dataset, like tabular model that refreshes from Synapse? Or is it Power BI data flows, like CDM in Tabular? Or,
yeah, great question. That's a tough one to answer. So, Data Factory doesn't really have a direct sort of input into Power BI. We essentially are writing data. And in most cases, most of the customers that I work with are writing that data into a data store, like a Synapse DW. I think I'm out when I say DW now. Synapse SQL pool. And in that case, when you do that, you're really just you're then going to build your models on top of it or do direct query from that. There is one other thing. Another very common pattern is to continue to write those partition files. Don't use the key partitioning that I mentioned for this case, but if you just say allow Factory to partition the files, it takes advantage of distributed environment that you're working in, which is Spark, without you needing to know Spark. You could take a large amount of gigabytes, terabytes of data, split those up across, let's say, 2,000 partitions, and then you can use analysis services in Power BI to read those partition files into analysis services partitions. So I have a large customer who's doing that right now, has been very successful at that. Those are two different mechanisms. It's kind of up to you in that regard. Data Factory doesn't have a one specific sort of direct way to write that data into Power BI. You just got to decide if you want those analysis services models or just write it to a database store.
Can I ask a quick question relative to that?
Yeah.
I'm sorry, quick question. So data flows, I understand, are known as CDM folders. And I mentioned that in my question. I understand that you can attach data lake storage in Power BI and then various products like Data Factory, I think Databricks, and maybe Azure ML Services can write CDM folders that then are immediately available as Power BI data flows. How does that work? And what is that like?
Yeah, sure. Let me quick. I think I have a minute just to quick show you something. So
Okay.
that is there. That is what's the word I'm looking for? I'm not going to say tricky. I'm going to say interesting. So what you do when let me actually show you an example here. CDM. There we go. So what you can do is you can both read and write CDMs. This one's not writing it, but in your case, what you would do is you would have, let's say, maybe some Parquet files that you want to process. Those would be in the lake. So let's do a data set type of, let's do Parquet. And then you could write out to CDM into your ADLS Gen 2.
Okay, so you're writing to CDM. Is that the actual common data service, or is it actually the format? Common, like a CDM folder?
Common data model is the format of the file sitting in the lake. CDS would be, the common data service would be writing to what's known as Dataverse, or essentially would be writing directly to Dynamics in that case. Great.
So this is a CSV plus a JSON file that defines the schema.
You decide. You can use Parquet or CSV, your choice.
Great.
Yeah, and then pick that up directly in PBI. Yeah.
Okay. Thanks. Appreciate that.
Yeah, no problem. Good question.
Great. There is one question related to video. I mean, I didn't ask you, Mark, at the beginning, that is it okay to share this recording? Because I'm recording it.
Now you ask me. No, of course it's okay. That's okay.
No, because that happened actually once. I was recording, it's recorded, but speaker said not to share. There is some data, so I didn't share. So that's the reason I should ask that class, but anyway.
No problem at all. I do see a question on the dedupe template, and I'm glad that was asked because I forgot to show it, so I can share again real quick. Sure. I did forget to show it. So I believe we have, okay, so there's two things. When you go to the YouTube channel or the links in the presentation I gave, I have got the real simple example. I could probably actually do this right here. If I go here, I'll show you in the docs. I put the simple dedupe right here. There's an article in the Data Factory documentation that I put with my video walking through it. And all you have to do is just take the snippet. So there's a snippet right here. You click on this, you take this, you hit copy, you add it to your data flow, and it'll automatically remove duplicates from your data. Super simple. If you want to get to the more complex one that I showed in the slide, that's a template. To get the templates, click New, Pipeline from Templates. Let's see. look for DUP, dedupe pipeline. You need data sets. That's fine. Just define your data. Tell Data Factory where your data sits in your lake, and then boom, it'll give you that. So that whole big, long, complex, ugly thing, it'll put it in your factory for you. Boom, just like that. And then you can go in here and you can change this as you like. So this one right here is this is for zip codes. You can say I don't care about zip codes. Take it out, change it. It's got the SoundX examples if you want to see how to do SoundX. It's essentially 3 button clicks and it'll be in your factory. Let's see. I can go up to the questions here.
Okay.
Now we try. Oh, simple. Got it. Oh, we talked about that one already. I think we might have covered them all.
Yeah. Mostly there is a last question from Sunday.
Oh, schema drift. I didn't show schema drift, did I? Do I have a minute to show schema drift real quick?
Sure, that'll be great.
Yeah, do it real quick. Schema drift. Schema drift is complex. I can't do it a fair treatment here, but I will at least introduce you to the concept. In the data flows that we were just working in, I'll just keep this one up for the sake of discussion. There's a checkbox called schema drift. There's more to it than that, but allow schema drift will say, when you have this turned on, here's my projection for my incoming data. Okay, this data has 37 columns in it, and it looks like this. If I click on allow schema drift and say date of birth changes to there's no spaces in it, let's say, data flow will just accept that and continue to work okay. The only instance where that'll be a problem is if I actually try to directly address date of birth with a space in it. So the way that you work around that piece is when you are building your transformations. Let me come out of this a little bit. When you do a derived column and you wanted to work with that column called date of birth, which was, oh, by this time I don't have it anymore, so let me go back over here. So I dropped some metadata at that point using a select transformation. So let's do a derived column, and date of birth is, I thought it was on here. There it is, date of birth. Okay, there we go, date of birth. So if this changes, what I would do is I would instead make a column pattern. So take that away, make a column pattern. In your expression builder, you do something like this. I am not good at regex, so I'm not going to do regex. If you like regex, it's probably better to do it that way. I'll do in-string because I'm kind of goofy like that. So I'm going to say name is a meta function. So I'm going to say if the name of the column has birth in it, let's just say birth. And let's say that we don't know if it's going to be lower or upper. So let's lower this guy right away. Let's go ahead and lower that. Are we too lower or lower? I always forget. It is just lower. So let's lower that. So if it is greater than 0, which means it matched, then I can do my transformation. So if my transformation before was, let's just say it was, I don't know, uppercasing it. Now I can just say upper, $, boom. This is how you protect against schema drift. So turn that checkbox on, and then if you're going to access a column directly that you think can change, do it as a column pattern instead of as a direct column. And now any time that birth is in that column, this transformation will be applied to it. It's a lot more to schema drift, but that can get you started at least. CDC examples. So we do have some examples online in the docs of using CDC change data within Data Factory. We can do that with SQL. Just remember that Data Factory is batch oriented, so a typical thing to do is to run that every couple of minutes, find the change rows, update the tracking table, the change tracking table, and then move on to the next iteration. That is and it's documented in the docs online. Awesome. So I think that is that the right time? I'm not sure if I'm ending at the right time or not. Actually.
No, I think yeah, you're almost there. Like it should be ended at 7:30. It's already 7:29.
Oh, good. Okay. Awesome.
Yeah. Well, actually, I'm not sure if am I allowed to ask any question. I have a question actually. I know there are a question from a lot of people. Well, Arthur has a question. Can you load external libraries in the ADF?
So you can't do custom libraries in data flows, what I was mainly focusing on today for this session. But in Data Factory All Up, you can use activities that do call your custom code, and that they can have external libraries. So you can do things in Azure Batch if you'd like to write it through Azure Batch. You can use Azure Functions. They can include any external whatever libraries Azure Functions allow. Typically, when I get asked this question, I will say use Azure Functions, use Notebook to do that. Data flows, Power Query, those things would be more for the sort of boxed set of transformations that you're going to work with.
Right. I think I'll shoot my question. I'll set a scenario. What is happening? It's a kind of problem. I don't know if you face it and how to solve it, or am I doing something wrong? For example, we have the event trigger. So anytime the CSV file dropped, and then there is a data flow. Say 3 CSV file will create a 1 Parquet when that data flow will be completed. And what happened is in the data flow, it doesn't create 1 file at a time. Since there is a, even since there is a trigger not only when the CSV file created, also there is a trigger when the Parquet will be created. But then, then the load pipeline will start and insert the data in the table. What happened is, as soon as it created the Parquet, it doesn't create 1 Parquet, it created multiple Parquet. So it means that as soon as it starts creating the Parquet, and then start shooting those events, which eventually, insert the data into the table. So, of course, at the end, it became only 1 Parquet, but, at the time, it's like, if you look at, I don't know exact the name, but there was many Parquet files created at the time of processing. Have you faced this kind of issue, or?
Well, what would you like to see? Did you want to see just 1 Parquet file output, or did you want to maybe put the Parquet file somewhere else that didn't have the blob trigger associated with it?
Yeah, I would like to have, only 1 Parquet. Of course, it's, as I said, it eventually created only 1 Parquet, but when it's processing, it has this part 001.
Oh,
It's
a good point. Yeah, I see what you're getting at. And I apologize to rush a little bit. I do have to. It's only 4:30. I have another call coming. I just realized. I'll answer it real quick for you though. Is that the what's happening is the way that it works in Spark land. This is something that we don't have a lot of control over. Spark will first create the partition files because everything is distributed to partitions. Okay, and so what will happen is when you say give me 1 file output, it takes those 10, 20 files and then it merges those together. So you do get it, at least temporarily on disk, you will get those 10 files. So the best thing to do is use a temporary folder to put those in.
We're doing that, Mark. We are doing that.
Oh, and it's still happening for you, is it?
No. I mean, that was the solution we did.
Oh, that was your solution.
That was the solution.
Hey, one thing to try if you want to try it this way is set 1 for the single partition across your data flow. That might fix it. That's the only other thing I can tell you to try. Just say 1 partition for everything. That's not optimal in terms of performance, but if it performs okay and you'd rather have a single file, try setting 1 for your partition.
I'll try that one, see if that works, but thank you so much. Oh, okay. This is ask very interesting is the end, but I think the question is, Mark, how come there is nothing about Synapse in this demo?
Oh, I know. So that's just me because I'm just so comfortable in ADF because I'm on the Data Factory team, but the whole product is essentially also in Synapse, and I could have done this exact same demo today all in Synapse, and I just chose not to just because I'm I guess I'm slow to change, and I should probably start doing it more in Synapse. But you can start from either place if you like. You can spin up a Synapse workspace and do the same thing if you'd rather. There's no reason not to.
Yeah, as Disney mentioned, it's not just a wrapper on an ADF. I mean, that's actually it is.
It is. I guess the better way to put it is that Synapse is a large solution that happens to have Data Factory in it. I think is a better way to put it. But I think you're saying essentially the same thing.
At the last time, we're gonna finish it now, but I would like to request you, Mark, put on your camera. That's for the social media. I have to take a picture.
Oh yeah, sure.
And then we're gonna end. Sorry to put you on the spot.
Where is that? I don't mind at all.
Okay, thank you.
It's dark. it's getting dark now. I see it was bright just at the beginning, and now it's going to be nighttime here.
Right. Thank you so much. It is so engaging, and I think we need more time to really cover all the things. It's
Oh man,
like
it could take me
super
days to get through
interesting.
all this stuff. You kidding me?
Yeah. Thank you, everyone. Thank you so much for joining. It's really great session, and thank you, Mark. It is awesome having you here. And you're going to share the PPT, and I will share with the audience today.
I'll send it to you.
Yeah, okay, great. Thank you. Thank you so much. Thank you. Bye.
Bye.